Coming up, we take a look at updates to machine learning and artificial intelligence with the Azure Machine Learning Workbench, a new solution that assists in the construction and delivery of intelligent, AI-enabled data models. We're going to show you how it can be used efficiently to understand data sets through profiling and visualization, increase the rate of experimentation, and monitor and manage your models wherever they're being used in production, all as part of a unified workflow. We're joined today by Sandhya from the Azure Machine Learning team. Welcome.
Thanks for having me on the show.
So congrats, you've just released updates to Azure Machine Learning. Now it's in public preview, and it's exciting to see the potential of this technology and really bring machine learning and AI-based systems into the mainstream.
That's right. Anything that requires human intelligence is an area of applicability for machine learning and thus AI.
Now, when I think about AI, I think about digital assistants like we have at Microsoft with Cortana, which really intelligently understand your requests and start to learn your preferences.
Yes, Cortana is a great everyday example. To add to that, AI is making forays into fields that are traditionally involving human intelligence, such as self-driving cars or even air traffic control, which require iterative, real-time modeling to predictively determine outcomes to ensure safety. Over the coming years, self-learning models will be applied to a number of everyday scenarios, and what we're trying to do here is to make it easier to build these types of applications.
Right, and there are a number of examples really across industries, but what are we solving for then in terms of bringing AI and machine learning into these everyday systems?
In building any intelligent system, there are a number of steps that you need to take, and typically there are 3 teams working together to accomplish these. The data scientists acquire and transform the data, building a deep understanding which allows them to build and evaluate models. This is an iterative process where the scientists might restart and experiment along different lines. Once the model is chosen, the operations engineers deploy it and set up the monitoring and management for these models in production. And the programmatic access to these deployed models are then embedded into code by developers, surfacing them in end user and business scenarios. So in the above workflow, there is friction in the handoffs between the data scientists and the operations. The models being deployed are often recoded, causing translation errors.
So I bet a lot of people are familiar with this problem. You've basically got a requester and a developer, and then there's this translation that has to happen, this back and forth before both parties get it right.
Yes, the data scientists lose visibility into the model performance as well. With Azure Machine Learning, the workflow is dramatically enhanced because we enable the operations engineer to encapsulate the model instead of recoding them, thereby reducing the noise in the system. Additionally, Azure Machine Learning provides capabilities to make the experimentation inner loop more efficient by reducing the time to prep the data as well as simplify the experiment evaluation.
So we've just released the preview now. What are some of the components that you've added as part of Azure Machine Learning?
So Azure Machine Learning is an Azure service consisting of libraries and tools, and these work together with your IDs and third-party libraries and tools. You can train as well as deploy on Azure Compute, such as HD Insight, VMs, GPUs, Azure Container Service, as well as Azure IoT. The service increases the rate of your experimentation by enabling the scale up and scale out of your training with no code changes. You can deploy the final model to endpoints of your choice right from your laptop. So Azure Machine Learning, in short, makes the AI solution development a lot easier.
All right, so let's make this real. Can you walk us through an example?
Absolutely. My team has been working with the Snow Leopard Trust, which is dedicated to conserving the population of snow leopards. This species has been classified as endangered, and there are less than 6,900 left in the wild. The trust has been tracking snow leopards using camera traps that sense motion and have collected almost 1.3 million images over the years. The challenge is, if you look at the image, you can see it's hard to decipher a snow leopard.
Right, and I'm looking at this and I can barely even myself see that because the snow leopard then is naturally camouflaged to really blend in with their environment. That's
right, it's even hard for humans. In fact, it takes the Snow Leopard Trust roughly 300 man-hours to manually sift through these images and identify snow leopards.
And it's really a vast amount of data that you're looking through. You mentioned 1.3 million before. How can we apply machine learning then to help with this?
So we can simplify the data cleansing and preparation of the metadata, and then we can train a classification model and operationalize it so that the Snow Leopard Trust can automatically identify snow leopards with the images taken by their cameras. Let me demo this for you. We are in the Azure Machine Learning Workbench and looking at the metadata that was shared with us by the Snow Leopard Trust.
So this is running on a Windows PC, but you also have a version for Mac OS, right?
That's right. We support both Windows and Mac. And what we're looking at is the metadata for the snow leopard images that were taken. And the metadata consists of a path column, which is a pretty long path, along with a couple of timestamps. And what we really want to do here for the data cleansing process is to actually break up that long path into its components. So what we're going to do is to use the PROS, which is program synthesis by example. So I'm going to say derive column by example. This is a cool capability that has been provided to us by the Microsoft research, and we've embedded that into the application. And right here, what I can do is actually just give it the image number that I want. In this case, the image number is 6756. And so I go ahead and type that in. And when I hit enter, what this is doing is the program is learning what I'm trying to extract, and it is going to extract it for me automatically. This is very cool because what it's done is it's not just extracted it for those rows that are just in standard format. It's also handling the rows that actually have extraneous characters, such as the parentheses that you see right there.
So here we've taken that long string and basically derived the image number, and this is one data prep task that data scientists might spend time writing code for. And right now, you've quickly done that using PROS.
That's right. Let me show you another example. So in the metadata that we got from the Snow Leopard Trust, we have it pre-categorized as other images, which are actually not the non-Snow Leopard images, and a folder with Snow Leopard images. So what I'm going to do here is to use the derive by example again, and I'm going to use this derive by example to give in a 0 or label of 0 for the other images, and a label of 1 for the snow leopard images. So I'm going to go ahead, give in the 0, and a 1 for the row, which is snow leopard images. And it's important to understand that this is a complicated extraction, and consequently is going to take a few different examples from me in order for the program to learn.
In this case, it's actually learning.
Yes, and I'm going to go ahead and give in a couple of more examples before it actually completely understands what I want. So I've given it the 5th example here, and what it's done is it's gone ahead and gotten that column. So let's go ahead and see what is in that column that was just extracted. I'm going to look at the value counts, and as you can see, it has 2 different values, 0s and 1s, and there are exactly 2,864 images that have been categorized as 0. So as you can see, with just a few quick examples, we were able to perform the data cleaning tasks.
So what's happening in the far right column of your screen?
So these are actually the steps that are being done, that are being recorded by the program. And what this helps us with is it helps me move back and forth between the steps that I'm doing and go try other things. It also helps me change the samples. I'm working currently against a small sample from the larger data set, but I can quickly go ahead and change this and run the exact same data cleaning task on the really large sample.
So then how do we go about training the system to identify a snow leopard from a photo?
So fortunately, in this case, I have a good starting point. The Microsoft Research's ResNet 50 is a great model that I can use as a starting point, and it has already been trained on 14 million images.
One thing to point out here is you can actually bring in pre-existing functionality. In this case, we're using MSR stuff, but you could use other sources.
That's right. Azure Machine Learning supports the use of open source and third-party tools and libraries. So using this model for classifying the snow leopards gave us an initial accuracy of 68%. But we can do better. So I can improve the accuracy score using a capability called transfer learning. I take the ResNet 50 and chop off the last few layers and replace it with a traditional machine learning classifier such as the logistic regression. I've leveraged the Microsoft Machine Learning library for Apache Spark to help me simplify the Spark coding. This library is open source and shipped with Azure Machine Learning. And once we did this, the accuracy jumped up to 89%.
So what's the experience like then if you want to start coding and operationalizing this data model?
So let me show you. I'm here in Visual Studio Code. This happens to be my favorite editor, but you could be using any IDE of your choice. And what I've done is I've gone ahead and put some logging statements, such as the line number 90, where I'm logging the number of output layers that I'm cutting. This is important because I'm going to compare multiple different numbers as I do multiple runs. And I'm also, if you look at line number 97, you can see that I'm training a logistic regression classifier. So what I've also done is added a few more logging statements to track the area under ROC as well as the accuracy. So let me go ahead and start a run of the snowleopard.py scripts on the HDI cluster that I've already created. And while this is running, let's actually switch over to take a look at the runs that I've already performed for the snowleopard.py from within the Azure Machine Learning Workbench. So here we are, and as you can see, there is an active run in progress, and there is also all of the accuracy charts that are coming up. And the important thing about this is that this allows me to compare the runs. In this case, what I can do is actually compare two of the completed runs, the number 7 and 8, and go ahead and take a look at all of the values, all of the output numbers that are coming out to see which one I really like and would like to go ahead and deploy. So I take a look at all of these numbers and make my decision. At this point, what the Azure Machine Learning Workbench lets you do is select that particular run and take a look at the outputs from that run and mark some of those outputs as the ones that you want to get tracked for a longer term storage in some sense. So in this case, what I am going to do is get into the run that I'm looking for and select the asset that I want and promote that asset so that I can then use it in my deployment.
So now we've prepped then everything that we want to build in terms of the model. We've done comparisons based on other experiments. So how easy is it then to deploy this into production?
We've put a lot of consideration into making the deployment of models easy. So once you have your assets tracked, you can come into the Azure Machine Learning Workbench. And this is actually the command line window for it. And I'm showing you that I already have an ACS cluster created and ready. And what is happening now is I am going to go ahead and create a service. And this is a real-time service for taking that particular model that I just trained and putting it into a Docker image and hosting it up on the Azure Container Service. So since this is going to take a little bit of time, let's switch over into an endpoint that I had set up previously. And what I'm going to do is to actually use two of the images, one with a snow leopard and one without, to score against this service. So let's take these two images, the one that we had seen previously and another one. And what we're going to do is to actually run that against the service. First, we'll try the image without the snow leopard. So I'm going to go ahead and give that here and wait for the service to tell me what the verdict is. And looks like it's not a snow leopard. So let's go ahead and then give it the image, which contains the snow leopard. And let's see what the scoring service finds out. And it says it's a snow leopard. So that was it right there.
All right, so now all this is running, but how can the Snow Leopard Trust then build upon this scenario?
This technology is very powerful. We have options to run these models locally right in the camera trap and reduce the memory storage, or we can stream it up to IoT applications. And in the future, we can further develop these models to recognize individual snow leopards by their unique spot patterns, allowing scientists to track individual habitats.
Okay, so we're able to create an intelligent and custom image recognition service really using Microsoft's AI stack. How can we apply the technology and techniques that we saw here to everyday systems?
So machine learning is being used in a lot of cool areas. One example I recently came across was of AI being used to predict whether a surgery patient is at risk of coming back with complications, thereby allowing doctors' offices to keep a closer tab on those patients through the recovery process. We've seen a lot of unique applications across lots of industries.
And I remember as we were working with the Renault Sport Formula One team, they were looking to use machine learning to predict whether and when to change tires and which compounds to use during a race. So the potential for this technology really seems limitless, and I'm looking forward to seeing where this goes. And how can people then learn more to get started?
You can learn more at the link below. Sign up for preview and let us know what you think.
And of course, keep watching Microsoft Mechanics for the latest updates across Microsoft and follow us on Twitter. Thanks for watching. We'll see you next time.